As we are recording correctly. Okay. So we are going to continue with what we were doing last time, which is how the user are represented in a Unix machine. So before we do that, I want to introduce a powerful command that is the date command. So the date command allows us to have information about the current date and time. So I can just type date and it will give me this information. So according to the country where you live, the information will be presented differently. So we are in the US. In the US, they say, for example, Tuesday, April 4 of April 4, 2023. We give the hours in AM and PM, so it's 2:33 PM, as you can see, and we are in the central daylight time in this moment. No, so we have both. We have the date and we have the time. Now this command is very powerful, and we have many formats how to represent the date. So I can do a man date to have some information. I want to work with the format, so I'm going to go to the format station, and we will see the different format that exist. So look, for example, a %A will give me the abbreviation of the day, the day of the week, like Monday, Tuesday, Thursday. So for example, today is Tuesday. So if instead of asking the full date and time, I can say, I just want to see, for example, the day of the week, which will be Tuesday in a 3 character. So look at, we have Tuesday in 3 character because %A is the day of the week on 3 character. If I want the full weekday, I can use %A. So if I ask, give me the full weekday, it will say today is Tuesday, as you can see. So, sorry. You can go there, and I like when I represented the year, the date, I like to use the year first, a dash, then the month, a dash, then the day. So look at, this is the date of today with the format that I like. I don't like the other format. I like year, month, day. So every time that I write a date, I write it this way. And if you want only the hours, you can say, show me the hours, for example, the minutes and the second. So %H will be the hours, %M will be the minutes over 2 digits, and %S will be the second over 2 digits. Oh, sorry, when we represent time, we separate the field with colon. So I'm going to put a colon here, and we have, it is 14:35 minutes, 38 seconds, as you can see. Of course, if I type it after, the number of seconds have increased because, of course, the time still passing, no? Okay, so maybe you would like to know which date was the 1st of January, 2023. So there are many ways to answer that. So look at, I can say, I'm not referring to the day of today. So with the option -D, I can specify a specific date. So for example, 2023, January 1st. And it will give me, for example, I want to see what day it was. So we know with the %A, we will have the day. So look at January the 1st, 2023 was a Sunday. So we also have a cal command, and I can ask the calendar of all the year 2023. So for example, today is the 4th, it's a Tuesday. And as you can see, January the 1st was a Sunday. So for example, if you want to know what day it was in the past, very long time ago, for example, let's say I want to know what day was 1970, February 25, which day it was. So here we have it. I can ask, of course, the calendar command to give me the day. So instead of using a specific date like that, you can say today. It's reference of today. I can write today plus 4 days. So what will be the date in 4 days? So today we are Tuesday, so it will be Wednesday, Thursday, Friday, it will be Saturday in 4 days. So it will show me that in 4 days will be Saturday, the 8th of April. So you say, I say today plus 4 days. You can write something like that. Today plus 2 years, for example, plus, let's put 5 months, plus 4 days. Let's say that somebody say, I see you in 2 years, 5 months, and 4 days. And you want to know when it will be. So you just ask this command date. And it tells you that we will be in the year 2025. The month will be September, and the day will be the 8th of September. Of course, you can say, oh, I don't like this format. Please show me in the format that I like, which is first you show me the year, then you show me the month, then you show me the day. I can ask, and it will say, okay, we will be in the year 2025. The month is the 9th month, which is September, and the day will be the 8th. As you can see, as we can go into the future, you might say, oh, can I go into the past? You can say, you can go to into the past. For example, somebody tell you this event happened 1 year and 10 days ago. So you can ask, okay, from today, give me the date 1 year and 10 days ago. So as you can see, I say today minus 1 year minus 10 days. So of course, it will be in 2022. We will be at this time in the 3rd month, which is March, and the day will be the 25th of March. That was 1 year and 10 days before today. So as you can use today, you can use tomorrow. You can use tomorrow. So for example, if I ask, what will be the date of tomorrow? This is the date of tomorrow. I can use yesterday. It's very powerful, as you can see, no? Yesterday. And it say that the day of yesterday was April the 3rd. Okay, I can use next also. For example, I can say next Sunday. What will be next Sunday? What will be the date of next Sunday? Look at, you can ask next Sunday. So it says that next Sunday, it will be April the 9th. Or I can say next month. Or I can say next week. For example, let's say next week. So today we are the 4 plus 7 will be 11. So next week will be in April the 11th. Let's put next month. So it will put 1 month from today. Or we can put next year. So 1 month from today, we will be in May 4, as you can see. Or I can say next year, or previous if you want also, no? Let's put next year. So I want to show you that this command is very powerful. So of course, next year will be in 2024. The month will be the 4th month, which is April, and the day will be the 4th as we are in this moment. Okay, so what I would like to show you also, there is a reference time, which is called the epoch time. Have you heard about the epoch time? So when was the epoch time?
January 1st, 1970.
Yeah, January 1st, 1970. You are right. This is called the epoch time. So epoch time is January 1st, 1970. So this is the reference time for Unix. The times start counting from this date in the meridian time, the Zulu time. You know that we have different time zone in the world. The reference time is the one that's passed over England, over London. It's called the Zulu time. This is from there, for example, we are in this moment 5 hours before them, no? We are -5, as you know, and sometimes we are -6. In this moment, we are -5. So we can also ask a date in second, based on how many seconds have elapsed from the epoch time. So for example, let me ask that. How many seconds have elapsed from the epoch time? So this will be the number of seconds that have elapsed from the epoch time. So we might want to do a computation to realize that this is the number of seconds, but you can do it and you will see that. So I might say, okay, let's see if it's work. Let's put a specific date. For example, 1970, first month, first day, and give me the number of seconds that have passed. So let's see what it will say. It doesn't say 0. Do you have any idea why it doesn't say 0? So this number will represent what? This should be, I think, 5 hours. Let's verify it. 5 times 3,600. It's more, so six hours maybe, because sometimes it's 5 hours. Yeah, 6 hours. Sometimes we have 5 hours of difference with London, and sometimes we have 6 hours. So of course, in winter we have 6 hours of difference. So this is 6 hours. Yeah. So when it was midnight, the 1st of January 1970 in London, what day were here? Exactly, we were in December 31st, 1969, on 6 hours from midnight. So it's why it showed me a number of seconds of 6 hours, because we have 6 hours of difference with London. So if I don't want to have this problem, I can specify the time zone. So I can say the time zone that I'm going to use is the Zulu time zone, which is the one of England. And I'm going to ask how many seconds have passed from midnight, January 1st, 1970. And as you can see, it says 0 seconds. So if I say, for example, here, that will be January the 2nd, 1970, what do you think should be the answer? 24 hours time 3,060 seconds per hour, no? So if I compute 24 hours time 3,600 seconds, we have the same number, because one day is 86,400 seconds. Okay, so you might say, can we specify also, for example, the number, the hours? Yes, you can say that. So you can say we were this day, and it was, for example, let's say 10 o'clock in the morning. So this, of course, should be, if it's 10 o'clock, it should be 10 times 3,600. And 10 times 3,600 is 36,000 seconds. So 36,000 seconds have elapsed from midnight, January 1st, 1970. Okay, if I say, oh, I just want to see how many seconds have elapsed, here, just 1 second have elapsed. For example, if I put this, we are 1 minute after the epoch time, 60 seconds, as you can see. If I put, for example, this 1 hour after the epoch time, 3,600 seconds, no? So this allows us to compute the number of seconds that have elapsed after the epoch time. Now, you might say, let's say I have a number of seconds and I want to know that have elapsed after, we want to do the inverse operation. I have a number of seconds and I want to know what was the date, for example, in London. So there is an option that is, you can specify, for example, the arrobas. If you specify the arrobas, after the arrobas, you say the number of seconds that have elapsed. So look, it will say that we are the 1st of January 1970 and it's midnight. Of course, I can say, okay, show me that a little better. I want this format. So let's specify the format that we want. We want, for example, the year dash the month dash the day. Then we want the hours colon the minute colon and the second. So it say that it's this is the epoch time, midnight, the 1st of January 1970. So of course, if I say, okay, 3,600 seconds have elapsed. So it will be the 1st of January 1970 and 1 hour after midnight, as you can see, 1 o'clock in the morning, as you can see. So we can go from a specific date to the number of seconds that have elapsed after the epoch time, or we can go from a number of seconds that have elapsed after the epoch time to a specific a date, no, to represent the date. So I might ask you, can we ask the computer what time it is in Paris in this moment? So we can do that. So we have a time zone, no? So we saw the time zone, but there is a file that is called time zone info. So I'm going to see the content of time zone, it is called. I'm going to see the content of this file. And as you can see, our time zone is US / central. We are in the central time in the USA. So this is our time zone. Now, there are many time zones in the world. So there is a directory that have the information of the different time zone. So I'm going to list all the information that we have. So you go to the directory user. Inside you find a subdirectory that is called share. And then we have a subdirectory that is called zone info. And it will show you all the different time zones. So as you can see, for example, we have a directory for Africa, where we'll have all the African country, for America, where we'll have all the American country, for Asia, for some countries that have different time zones, that are big country, for example, like Canada, which have at least 4 time zones like us, Brazil that have several time zones, will have their own directory. So for example, if I want, look at, we will find here, the US, of course. So I can look at what we have inside the US, and you will recognize the time zone that we are using. For example, the central time zone is normally the time zone of Chicago, no? And the Eastern time zone, for example, will be the time zone of, I think it's New York. Let's see, Eastern, I say POSIX rule. Okay, but it's the time zone of New York, no? For example. And after that, we have the mountain time zone. It's the time zone of Navarro. And then we have the Pacific time zone, the time zone of Los Angeles in California, as you can see, no? So my question was, what time it is in this moment in France? So we do have a directory for Europe. And as you can see in Europe, we will have the capital of the country, like Rome is the capital of Italy, for example. Paris is the capital of France. So I need to see if Paris is there. And as you can see, we have Paris. So I can check the time zone of France by doing Europe/Paris. So look at, I'm going to do time zone equal Europe/Paris. And I'm going to say, give me the time and the date and the time that is in Paris without doing formatting. So it's saying that in Paris, it is also April 4, 2023, and it's 9 o'clock p.m. No, as you can see, 9:52 p.m. instead of being 2:52 as we are here. So we have 7 hours of difference with France, no, as we can see. Okay, so this is a way to get a specific time, a specific hour in the world. So why I wanted to see this command? Because we will need it. Because there are many dates that will appear in the lecture that we are going to see today. So I want to talk about the file that we will be using to store the information of the user. So let me go through those slides and go directly. So in Unix, you have several accounts. You are already familiar with the root account. It's an account that always exists in all the Unix operating system. And this is the administrative user. It is always there with a user ID of 0 and a group ID of 0. Then you can create account for people. Like for example, in this virtual machine, we have an account that is called Eric for the user Eric Games, no? And you can also, when you install software, they can create account for this software. For example, when you install Apache, the web server, create an account that is called www. So sometimes you have accounts that are created for a specific software. If you install the Dockers, there will be an account that is created to manage the Dockers. And this account is called Docker. Okay, so you have several types of accounts. And information that you already know about an account is the username and the password. A user also has a home directory. Normally the home directory of user are inside the directory /home. The root user have its own directory, which is /root. But if you create a user Eric, it will be in /home/Eric. If you create a user, let's say David Smith, D Smith, the home directory of D Smith will be /home/D Smith. No? Okay, so user in Linux, the first user will have a user ID of 1000. The second user that you create, we have a user ID of 1001, and it's go from 1000, it's go up. Every time that you create a new user, its user ID will be incremented, starting in 1000. So in the virtual machine that we have, I think we have only one user, and this user will be user 1000. Let me see, let me go there and ask the ID of Eric. So as you can see, Eric has a user ID which is 1000. And if we have other user, there will be 1001, 1002, 1003, etc., etc. But we have a user ID, which is a number that identifies us in a unique way. So there are several ways to store the information of the user. For example, you can have a service that is called LDAP, but you can also have a file that is called /etc/password. This is the file that I want to see today. It is stored locally, and it's a comma-separated file. And the separator is a colon. It's not a comma. It's a CVS file. CSV file. No, they say CSV. No, comma separated value file. But the separator is a colon, as we will see. So the three files that are important to store information of the user are those files. The etc password and the etc shadow is the one that we are going to see today. So let's talk about the etc password. So as I was telling you, we have several fields there, and they are separated by column. So the first field will be the username, like for example, Eric. Then the second field is not used anymore. So it's a legacy field. Here we used to have the password encrypted with an algorithm like this, or a modification of this. So here today we will have an X, and this X means that the password is not there anymore, is in another file. And this other file will be the etc shadows. So they move the password from the etc password to the etc shadows. Then we will have the user ID. For example, for the user Eric, the user ID will be 1000. Then we will have the primary group ID. So a user can belong to several groups, but there is always the actual group or the primary group. When I log into my account, I must be inside. Actually, I must be inside a group. So that will be the primary group, but at any time I can switch to any group that I belong to. Then we will have the GCOS information. So the GCOS information, for example, is the full name of the user. And if you want to add some other information, for example, you want to add the extension where the person works, the office number, you can add that in the GCOS information. So let's say that you want three fields. You want the first name and last name in one field, separated by a space. You want, for example, the office number, and you want the extension. So you will put Eric space Games, comma. Let's say that you want after the office number, my office number is AH for Earth all 234. So you put that, comma, and my extension will be 54, 52, or 52, 54. I don't remember in which way, but that will be what you put in the GCOS information. Then you have the home directory, /home/Eric in my case, and the default shell. It will be /bin/bash in the majority of the users. So here you have information in the slide that explain you every field, but I just mentioned them. So what I'm going to show you is this file that we just comment. So let me exit here. Let me switch and be an administrative user. So let me verify that I am the root user, as you can see. The first file that we want to check is this file, the etc password file. Okay, so we have not seen the rights up to now, but those are the rights on this file. So those are the rights of the owner of the file. The owner of the file is the root. So those are the rights of the people that belong to this group, which is the root group. And those are the rights of the other user. As you can see, only the root user can read and write the file. The other user can only read the file. So any user can read the file. So it was like that from the beginning, and it's why they moved the password from this file to another file, where the normal user cannot read the password. So let me show you the content of this file. So this file, remember, is readable by any user. So this will be the content of the file. Let me expand a little so we see a little better. So last time we create a user that is called Michael Johnson. Oh no, Michelle Johnson. So as you can see, this is the login of Michelle Johnson, M. Johnson. Then, as you can see here, we should have the password. We don't have the password anymore because we move it to the other file, which is the etc shadows. Then we have the user ID. So the first user of the system was Eric, and its user ID was 1000. Then we create a user that is called John. His user ID was 1001. Then we create Michelle Johnson. its user ID is 1002. Then we have the default group of Michael Johnson, Michelle Johnson, sorry. So as you can see, the default group is 1002. We'll come back to that. This is the GCOS information. In this case, I just wanted to store the name of the first name and last name of the person. Then we have the home directory, and then we have the shell that the person will be using when the person log inside. So what I want to show you is that here, for example, I am user Eric, and I can see the content of this file. So if I do a cat to see the content of this file, I will also be able to see it. As you can see, I can see it. So it's why they move the password information to another file. So let's see the other file now. The other file is the etc shadow file. So also it's a CVS file. CSV file, no? CSV they say? Yes, CSV file, comma separated value file. The fields are separated by colon. So first, we will have the username. Then we will have the hashed password. Then we will have several information about if the account is valid or not. So here we will have the day since the last time that the password was changing. So it will be the number of days after that have elapsed after the epoch time. Then we will have the minimum amount of day that a user have to wait before 2 consecutive change of the password. So what will be a good value here? What do you think will be a good value for minimum day? Which is the number of days that must elapse between the change of the password, 2 consecutive change of the password. What do you think we should put here? If we put 10 and I change my password today, what does it mean? I have to wait 10 days to change it again. You understand? It's the number of days that I have to wait after I change my password and before I can change it again, between 2 consecutive change of the password. So will 10 be a good value? What do you think? If not, if for you 10 is not a good value, what will be a good value? What will you recommend to put here? $60? 1 month? So if I change my password today, I have to wait 1 month to change it again. The system will not allow me to change it during 1 month. So do you think it's a good policy? So what will happen if I realize that somebody get my password? I change my password today and 2 days after, somebody saw me typing my password and I have to wait 1 month. Of course, it's 2 days after, so I have to wait 28 days. So waiting 1 month is not a good idea. So what you will recommend here?
1 day. If like their account was hacked and the password was changed.
So let's say that I decide to change my password today. I change it. And then I turn and I see somebody that was glancing on my shoulder. So if I have to wait 1 day, I cannot change it right now. I have to wait tomorrow, but this person did see my password. This person go away from me and have my password. So what will be your recommendation? 0. Put 0. Allow the person to change the password right away. Or for example, I change my password and then I say, I will never memorize that. So better let me now that it's still in my brain, let me change it to something that I can memorize. So you just change it and you decide, no, this is not a good one. I will forget it. Let me change it right away. So you allow the person to change it right away. If you put 1 here, the person has to wait 1 day. So in one day, we can have the two possibilities. The person might say, oh, this is not a password that is good to me, I prefer to change it right away. Or somebody saw me while I was changing the password, so I need to change it right away. So we are going to put better here 0. So look at max day is the maximum number of days that can pass before you force the person to change the password again. So let's say that I change the password today, and you put 60 here. Within the 60 days that come, I have to change my password. I can keep my password only 60 days. It cannot be longer than 60 days. So if after 20 days I decided to change it, again the 60-day ran. So from the last time that I changed my password, I have up to 60 days to change it again. So what will be a good number here? So that will depend on where you work. Some company will force you to change your password every month, every 2 months, every 3 months. For example, GSU does not force us to change our password because there is something that is also helping now is the 2-factor authorization. If somebody gets your password, he cannot enter, for example, in your account if he doesn't have your cell phone. So it needs to have your password on your cell phone because you will receive a notification to push so you can enter your, for example, your Canvas account. So it's making it a little more difficult. So it's why they don't force you that often to change your password. But in the past, when we didn't have the 2-factor authentication, it was very common that a bank, after 3 months, when you enter, you type your password and the bank say, you need to change your password. And it will not allow you to continue if you don't put a new password. So that's the maximum of days that you can use the same password. Okay, so if you put 60 days here, you change your password today, you have up to 60 days to change it again. And every time that you change the password, the 60 days start to run again. So warm days. So let's say that they force me to change my password every 2 months, every 60 days. And they put here as a warning period 10 days. It means that 10 days before my password is going to expire, which means 50 days after I change my password, every time that I log, the system tell me, hey, remember you need to change your password because in a few days it's going to expire. So it's just a warning. So if I put, let's say I put here 60 days and I put here 10 days, 50 days after I change my password, it starts warning me. You need to change your password. Every time that I log, remember you need to change your password. So it's just a warning to tell you, remember you have up to 60 days to change your password, to have a new password. So that will be the warning period. Let's say that after you start receiving the warning, you don't pay attention. And we arrive at day 60. Your password your password expire. And then you enter in a grace period. This grace period, let's say that we put here 15 days. It means after your password expire, you still have 15 days. So when you log, it will not only warn you, it will force you to change it during 15 days. And if in the 15 days you don't change it, when you log, it will not allow you, remember, it will not allow you to access your account. It will say you need to change it, you have to change it. It's not a warning, it's you have to do it. If you don't do it, I don't allow you to enter. So you do it. If you don't do it, after 15 days, your password gets invalid. And you need to go to the system administrator and go there and say, oh, I'm very sorry, system administrator, I was not taking care of looking very seriously the message of warning. I didn't change my password and didn't enter my account during the grace period, and my account is locked today. Can you please unlock it because I need to work now on the computer? Okay, so this is the grace period that they give you. So you can still, if you want to use your your account, you can still do it, but you will be forced to change your password. And there is a last field that is called expire. So let's say that we receive a visiting professor here, and this professor will be here until the 16th of December of 2023. So we can put here a date saying that the account have to be locked at this date because this person will be here until December 16, 2023. So every time that he log, he can log. But after this date, when he tries to log, he cannot do it because this person is employed by JSU until this date. So after this date, the password is disabled. It cannot log. Okay? So we use this field for that. So here you have information about all the field. So what I'm going to show you is, for example, that with a real case. So let's see the first, before we see the content of this file, let's see the right that we have on this file. Here I'm the root user, and I want to show you the shadow file, which is the second file that is important. So first of all, let's see the rights. So this is the shadow files. Look at, normal user cannot see the content of the shadow files. So for example, in this window, I am Eric, and I'm going to try to see the content of the shadow file, and it's going to deny me the access of the shadow file. So look, if I try to see the content of the shadow file, I say permission denied. You're a normal user, you cannot see inside. It's why we move the password in the shadow file, because in the shadow file, the people don't see the password. So it's a little more protected. But remember, the password is hashed. So even if somebody could see the shadow file, it cannot do a lot with the shadow file because your password is hashed. And if you don't use an easy password, there is no way to guess the password. So now I'm in the other window, in other shell, where I am the root. I'm going to see the content of the shadow file. So this is the shadow file. So this is the line of Eric. Remember, we have values that are separated by column. So here, this is the logging of Eric. This is the password of Eric, the hashed password. So look at, it's exactly as we studied previously. We have a magic number. Then we have between dollar and dollar, we have a salt. And then we have the encrypted field after the salt. So this is another algorithm. The algorithm that we saw was the $1, which is MD5. This is SHA-512. Okay, so this is what? The number of days that have elapsed since the epoch time when the user Eric last changed his password. So we know when this is a date at the end. When was the last date that the user Eric changed his password? So if I want to know the date, how can I compute the date with the date command that we have seen? For example, I know that since the epoch time, which was January the 1st, 1970, it have passed 19,000 days, 254, the last time that the user Eric changed his password. So what was the day when he changed the last time his password? How can we compute that? So you remember the command date. We can do, for example, /d @0. And /d @0 will tell us what date we were at the epoch time. So here we were on December 31st, and it was 6 p.m. here. So now what we need to do is to change this 0 in what? In the number of seconds that have elapsed since the last time that the user Eric changed his password. So what should I do to do that? What should I put here after the arrobas? I need to do a computing, no? And this computing will be what? 19,254 days. On a day, I have 24 hours. On an hour, I have 2,600 seconds because it has to be a number of seconds. So look at the last time that user Eric changed his password was on September 18, 2022. This is what this 19,254 mean, because it's a number of days after the epoch time. What does this 0 mean? If user Eric changes his password now, he can change it right away. You have to wait 0 days to make a new change. What does this 99,999 mean? This represents infinite. So what does it mean? The password that user Eric have is valid for an infinite number of days. So we don't force user Eric to change his password, which is a bad policy. Okay? What does this 7 mean? In case that we force user Eric to change his password, 7 days before the password become, before the password expire, we will start warning him, you need to change it, you need to change it. But that will be only a warning. Here we don't have value between the colon and the colon. But what should we put here? The grace period in day. Let's say that the password have expired. So if we still allow the person to log in and force the person to change the password, that will be the grace period. We don't have a grace period. And here we don't have a value, which means that the password of Eric never is going to be blocked. Okay, you put a date here for people that have a contract in the company. They will be working for 2 years until this date. So the password have to be valid until the date that the person leaves the company. So of course, if the employee is a permanent employee, you don't put date where you lock the password, because the person is a permanent employee. So okay, so here we have the information of the user John, and here we have the information of the user Michelle Johnson. As you can see, the user John, we were doing a practice, use another algorithm. It doesn't use the algorithm 6. It uses algorithm 1, which is MD5, the one that we saw last time. And Michael Johnson also, the password was hashed with MD5, as you can see. Okay, so what I want to do is, let's say that we are in a company that force us, that allow us to keep the same password up to 60 days. So this information maybe like that is not clear to you. So there is a command that is called change age dash show me list the information related, for example, to the user Eric. So look, it's the same information. So look at the last time that Eric changed his password was September 19, 2022. So here we compute September 18, 2022, because Eric might have changed the password late in the night, and it was already the 19th. So when I did the computing here, I suppose that he changed the password at midnight, but it might have changed the password after. So it's why it can be 18 or it can be 19. So here it's a 19. So look here, this 7 is the number of days that we will warn the user before the password expire. So the password never expire. You remember this 99,999, this is the password never expire. So for example, account expire never. So this is this field that is there between this column and this column is where you put a date saying the account is going to expire in a specific time. So what I want to put here, I want to put, for example, instead of infinite, I want to say they can keep their password up to 60 days. So the way to do that for the user Eric, we have an option that is capital M for maximum. And if I put 60, I say the user Eric will be allowed up to 60 days without changing his password. So I do it, and then if I look at the content of the file, look at here. We used to have 99,000. Now we have 60, which means that Eric can keep his password, the same password, up to 60 days. So I want to give him also a grace period of 20 days. So, which means after the 7, we have nothing here. We don't have a grace period. I want to give him a grace period of 20 days. Let me put 20 days here before the inactive period. So the I for inactive period. Now, instead of showing the information of all the user, let me just show the information of Eric. So look at the information of Eric now. I have a 60 here. So remember, I have a 20 here, sorry. It doesn't have the 20 before. So you remember that. It can change the password right away. It can keep the same password a maximum of 60 days. 7 days before the password expire, which means in day 53, I will start warming it. You need to change the password. So day 53, 54, 55, 56, 57, up to day 60, I will warm in. You need to change the password. If it doesn't change the password, starting on day 60 up to day 80, because it's 60 plus a grace period of 20. So start it on day 60 up to day 80. Every time that he logs, he will be forced to change his password. It's not a warning anymore. You have to change the password. If he doesn't do it, after 80 days, the account gets locked, and you have to go to the administration, the system administrator, and ask the system administrator to help him to recover access to his account. So to understand that better, let's compute first the number of days that have elapsed since the epoch time. Can you tell me how many days have elapsed since the epoch time? How can I compute that? With the date command. So with the date command, I can say, tell me the number of seconds that have elapsed since the epoch time. This is the number of seconds. So how do I get the number of days? I need to divide that by the number of seconds that we have in a day, and it will give me the number of days that have elapsed since the epoch time. So I'm going to take the result of that, of executing this command, and if I do it like that, it will just show me more or less the same value because some seconds have elapsed since then. So I'm going to take that and divide it by 24 hours and divide it by 3,600 seconds, which is 1 hour. So look at, since the epoch time, 19,451 days have elapsed. So look, the last time that user Eric changed his password was this from the epoch time, and with the command with this, we could know that it was September 19, 2022. Now here I am user Eric. I'm going to change my password. So it says, what is my current password? Internet 2. password, current password, internet2. I think I know what is happening. My account is locked. You know why I say my account is locked? Because of the thing that I put there. So let me do it as an administrator. Change the password of Eric. So what is the new password? Let's put hello. Hello. Okay. So now I will ask, show me the information of Eric. So it say, the last time that Eric changed his password was on April 4, 2023. Now, if I look at the information of Eric, this is the number of days that have elapsed since the epoch time, the last time that Eric changed his password. We compute this and look at, this is our computation. And as you can see, it's the same value here, 19,451. They have elapsed since the epoch time. Okay, so now I want to play with the clock of the computer so we can see what will happen in the time. So can you tell me, with the parameter that we have, when is the warning period is going to start if Eric doesn't change his password? So remember, no, I just changed my password. I can keep my password without changing it 60 days. But 7 days before the 60 day, I will be starting receiving warning saying, hey, you need to change your password, remember. So just a warning, a message that, hey, remember to do it. It's up to you if you do it or you don't do it, but remember to do it. So when should I start receiving warning from today? In 53 days, no, isn't it? In 53 days from today, I should start receiving warning. So let's compute what date it will be in 53 days. How can I do that? So the command date is magic. You can say, please let me know from today plus 16 days minus 7 days. You see what I'm doing here? 16 days, I can keep the password, but the grace period starts 7 days before. I could have done plus 53 days, but it's the same thing. So dash date. Today, oh, day is misspelled. Okay, so on Saturday, 27 May, I should start receiving warning. So what I'm going to do, I'm going to change the time of the clock of the computer, and try to log in the future to see what happened. So look what we are going to do here. If I change there is a way to change the date, which is the command date dash set. So for example, let's say that the date of today, as you can see, is April 4. Let's say that I want to put April 6. So I can say year 2023, month 4, on day 6. So look at the date. Temporarily, it went to April 6, what I asked, and it went back to April 4. What happened here? What do you think happened here? Why it went back to April 4? Why you never have to change the time of your computer? On your computer, always have the correct time, like this one.
Just checking an external time server.
Exactly. There is a protocol that is called NTP, Network Time Protocol. On my computer, go with an external clock. Check the clock there and synchronize with this clock. So even if there is a drift of time, because my clock doesn't work well in my computer, I will always have the correct time. Why? Because from time to time I synchronize with a site in the internet that have an atomic clock. We have quartz clock in the computer, which is very cheap and drift. So every year it will drift 2 or 3 seconds. The quartz clock drift 2 or 3 seconds. The atomic clock drift in millions of years. It will drift 1 second in millions of years. So there is no problem with atomic clock, but an atomic clock is very expensive. You are not going to put an atomic clock in a computer. Otherwise, the price of the computer from $1,000 will go to $12,000. Okay, so we put a quartz clock that drifts, and we compensate that with the network time protocol, and we do that. So I want to tell the computer, I want to disable the network time protocol. Don't use the network time protocol, so it cannot synchronize with the clock in the internet. So there is a command that is called time date control. Let me do show. So look at it, say my time zone is US Central. And do I use the network time protocol? Yes. So I'm going to say set network time protocol to false. Now, if I look at it, do I use network time protocol? Not anymore. So now I can change my date. For example, within today, on first day, and it will not go back. So look at, if I ask what is the date now, it's still first day. So I'm in the future. I'm today in the future. You see, it doesn't change back because it's don't use the network time protocol. It don't synchronize with the clock in the internet anymore. If I look at, if I do that, true, it will just take a few seconds before it's synchronized again. So it's still, I've not synchronized. It's synchronized maybe every 20 seconds. Okay, it already synchronized, as you can see. Every 20 seconds, you go to the internet, give me the time. Oh, I've drift. I put the correct time again if I drift. So we are back to today. So let me disable again the network time protocol. Let me put it in false. So we can say that we are in the future with the command set. So we already know that we are going to receive the warning according to this. We are going to receive the warning on May the 27th. So let me put us on May the 26th. So look at, we are on May the 26th, sorry, on May the 26th. So as you can see, we are on May the 26th. And let me log into the computer. So secure shell, Eric at localhost. Localhost. So we don't have a secure shell server. Let me install it. apt-get update. Oh, I think it doesn't like the I should have done that before. So let me put it, let me go back. It says that there are problem with time, I'm pretty sure. So let me do it. Now I did it because my clock is okay with the rest of the internet. So let me install the Open Secure Shell server. Yes. And now we have a secure shell server. So let me again disable and let me go in the future to the day that we say. So we are one day, we are on May 26th, one day before I start receiving the warning. So let me, I am at home and there is a server in my company. I try to log inside. So let me try to log inside. Local host. Okay, so It's saying, what is my password? My password is hello. And look at, I typed my password, there were no warning. The warning will come just after typing my password. As you can see, I log into the company, there is no warning. So now let me put the warning start on the 27th, but at what time? That's another problem. So let me try to log on the 27th. Now we are on the 27th, I try to log. So it asked me my password, let me put hello. There were no warning. After my password, there were no warning. Why? Because when I change the time like that, it's 27 midnight. So let's put 27, but let's put, for example, 10 o'clock. That the warning will already enter in the warning zone. So let me put 10 o'clock. So we are still at 27, but not midnight. It's 10 p.m. So let me log at 10 p.m. the day that my warning starts. So hello is my password. And look at, you see, after my password, warning. Your password will expire in 6 days. So I started receiving the warning. I'm lazy, I walk and disconnect. So let's do 2 days after. I'm still in the warning zone. So I connect again. I put my password, hello. So it say, you still have 4 days that you can use the password. I have a warning this time, but it doesn't say 6 days. Say you still have 4 days before your password become expired. So it's not expired. So let me add another. Oh, let me do. I don't know when it will be. So let me do date. This plus 4 days. So we know which date it is. Plus 4 days, it will be 1 plus date dash D is missing. Okay, so June 2 is when my password expires. So let me go to June 2. June the 2nd. So I'm early in the morning, my password have not expired. So I try to log and I will just have a warning. Where is the user Eric here? Which we're doing it here. Yeah, we were doing it here. No, we're doing it here. So who I am here? I am Eric. So let me secure shell as Eric in localhost. Localhost. What is your password? Hello. So it will expire in 1 day. So it will expire on the 3. Okay, let me put the 3 early in the morning. So let me enter this time on the 3 early in the morning. Hello is my password. So I have a warning that says it is expiring today, a little later. We are midnight, early in the morning. You are working, that's fine. So look, the same day, I tried to log at 10 p.m. late in the night. So my password are already expired. So when I try to log, look what will happen. So it say, give me your password. I put hello. And look at what it say. You cannot enter if you don't change it. So it forced me now to enter because I entered the grace period. So let's say, I don't want to change that. I don't work today. Okay, you don't work today, you cannot enter. So let's say that I don't want. Or unfortunately, I have a travel, I don't work for several days. So we have how many days of grace period we put for Eric? Let's see that. In the ETC shadow, we will have the grace period. So we put a grace period of 20 days. Okay, so what does it mean? So on 3, I start the grace period. The grace period will end on 23. So if I start to log on 23 early in the morning, this is 20 midnight. I am still in the grace period. So it's saying me, what is your password? Let me put hello, and it say change it. You need to change it if you want to log. And either I'm mad at the company, I'm not going to work. I'm not changing they ask me to change the password too frequently. I don't want to do it. So it has been 20 days that I didn't log into the computer. Now let's simulate that I got a call from my boss and it said they're going to fire you if you don't work. So at 12 p.m. in the night, at 10 p.m. in the night, I decide, okay, my boss say they're going to fire me, I'm going to work. So the system sent me, give me your password. I put hello. Now look, the grace period is over. So this time, the system does not ask me, what is your current password? Give me the new one, give me the new one. Why? The grace period is over. So now what should I do? I need to go to the system administrator and say, I'm sorry, can you unlock my password? So you understand how it's work? So you have a maximum of time you can use your password. You have a period that you will start having warning that say, hey, remember, you need to change your password. You still have that much day to change your password. If I don't do it, I enter in the grace period. For example, here 20 days. But the grace period, that means that I need to change my password. So let's go back. Let's say that the grace period started on 3, you remember? On June 3. Let's say that on June 4 at 10 in the morning, so we are on June 4 and it's 10 in the morning. I log. So I put my password hello, and as a good employee, it say, oh yeah, your password, you have been using it for 60 months, 60 days. Now you need to change it. So it say, give me your current password. I put hello. Give me your new password. So let's put, if I put an easy, it's not going to let me put an easy. For example, let's put Jacksonville. 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 Oh, okay, it did allow me. It didn't check in the dictionary. So it closed the connection. So it forced me to re-enter. So I tried to re-enter. It's saying me, what is your password? Now my password is Jacksonville. So I was forced to change my password. And look, I could log as Eric. Let me exit. I could log as Eric, as you can see. So you understand? So if you look, I did give you some information about that in exercise 8 that I sent you recently. So let's see it again. So toward the end, you have the information. So you have something that will give us. So look at. This is the last time that you change your password. So better this minimum period, you put it in 0, which means that I just changed my password, I can change it right away. Because I suspect that somebody gets my password, I need to change it right away. So put that in 0. So remember, the maximum password, we put 60 days. And this is the warning. So 60 days minus 7 days of warning give us 53 days. During these 53 days, I log, there is no warning. From day 53 to day 60, I got warning. You still have 7 days to change your password. Then it say you still have 6 days to change your password. You still have 5 days to change your password. Then it say you still have 0 days to change your password, which means that your password is going to expire today. Then if I still don't change it, I have the grace period. We put 20 days here. So in these 20 days, I can, when I try to log, the system will force me to change my password. If I don't change it now, I need to, in this period, which is 80 days after, I need to go and see the system administrator and apologize with the system administrator because I didn't listen to the security policy of the company. Our company have security policy and we have to, they enforce it, of course, and we have to respect that policies and work with what they say, no? So, you understand how we manage the password, how we change the password, how we force the people to change the password in this operating system. So now I want to show you, let me put the password of Eric back to Internet 2. Because if I don't do it, next time that I try to log, I will not remember that I put Jacksonville, and then I will not be able to log. So in this moment, Jacksonville. Okay, let me put password of Eric. A way to change the password of Eric is like that. You do echo the user Eric. I want his password to be, for example, Internet2. And you send that to the command change password. So now the password of Eric is Internet back. So Eric have the password Internet. Okay. So let me show you something. We are going to create some users, but we are going to create very novice users that don't care about the security like I see very frequently. So let's create a user with the command user add. This person will use, the shell that this person will use is bash. We want to create the directory of this person. Let's say that this person is Bill Carpenter. And the login will be B Carpenter. So we don't have this person in the system in this moment, no? So if I do a cat of the etc password file, look at it, add a new user. Why it add a new user? Because I add a secure shell server, and the secure shell server need a new user. So the last user that we add was Michelle Johnson. So let me add this user. Now, if I go and see this file again, we have a new line for Brian Carpenter, for Bill Carpenter. So B Carpenter, the password is not there. The user ID is 1003. His name is Bill Carpenter. That will be his home directory. And this is the shell that he used. So let me go as an administrative user here also. I want to see the etc shadow file. So look, in this moment, you already know all those fields because we saw them. There is no password for Bill Carpenter. Let me put a password for B Carpenter. So I can do, for example, password B Carpenter and type it. Let's type, for example, let's type Ayers in our case. Ayers. Okay, so the password have been added. So look at what algorithm did I use to hash the password of Bill Carpenter. MD5. Why I know that I use MD5? Because of $1. If you see $1, you use MD5. If you see $5, you use what? SHA-256. If you see $6, you use SHA-512. So by default, I asked the system to use MD5 because we were seeing MD5. We did a program. So let me go to the home directory of Eric. In the desktop, we did a program, a Python program. What was the name of this program? Compute password hash. Okay, we did compute password hash. Let me just show the information of Bill Carpenter. So grep B Carpenter. Okay, so this is higher encrypted. How can I verify that with the program that we did? So I'm going to say encrypt higher and use this salt. Remember, the salt is between the dollar and the dollar. This is the salt that was used. So look at it, saying the hash is this one. So compare this hash with the one that is in the file. The one that is in the file is there. They should be equal. As you can see, they are equal, no? You see that they are equal? Okay, so it's higher. The password is higher. Now, let's create some new user. With, for example, I'm going to create a new user. Let's call it Mary Smith. And Mary Smith is created. Let's put a password for Mary Smith. So I'm going to do echo Mary Smith. Have a password that is, for example, she just put one letter, capital H, which is very bad. So I'm going to send that to change password. Okay, so if I look here for Mary Smith, this is how a capital H is going to be encoded. So let's verify that with our program. I want to see how a capital H is encoding, and I know that the salt is this. And as you can see, it's exactly the same one. No, for example, it ends with AD2S1. It ends with AD2S1, as you can see. So it's exactly the same one. Okay, let's create another user. That's, for example, let's create Boris. Is Boris double S, double R, or only one R? Only one? Okay.
I think 2 R's.
So maybe it depends on the people. Yeah, because first name don't have a specific way to be written. So maybe some people, okay, let's put it with 1 R. We can Google it. Maybe there is more people that write it with 1 R than people that write it with 2 R, or vice versa. I don't know. But let's say that we have a Boris Clinton, and his login is Boris, for example. Okay, let's put as a password for Boris. Let's put, for example, something that key. The password is key. And let's create a third user. For example, Ed Thomas. Douglas. Let's Douglas. Ed Douglas, and it's logging E Douglas, for example. Douglas. And let's put as a password for E Douglas. Let's put maybe 2 letters. He puts AX. So what will happen? Let's say that somebody have access to this file, the shadow file. So for some reason, the shadow files, somebody could get a copy. So this person doesn't know that the password of Boris, for example, is, what is the password of Boris? Is key. But because look at how we see the password. Here, there is no way for us to guess that this password is key because it has been hashed using MD5. As we have seen, with 1,000 iteration of MD5, if you remember. So this person can install a software like John the Ripper. And John the Ripper, you give it this file and it brute force attack it. So let me install John the Ripper. First, let's see if we have John. Install it. We don't have it. So I'm going to do apt get install John. So it's a, do you want to install John on the dependency? Yes. So it download John on the dependency and install John on the dependency. So now we have John the Ripper installed. So this software is called John the Ripper. And John the Ripper is a software that you will give it etc shadow file, and it will try, for example, a password of 1 character. So how many passwords of 1 character can we have? So it can be a digit, it can be a lowercase letter, a uppercase letter, and the special character like a star, a plus. So how many do you think we can have? So 26 plus 26 plus 10 plus the letters, it's not a lot. It's less than 100. So it try all the password of 1 character, then all the password of 2 characters, then all the password of 3 characters to see if it can find the hash. So I'm going to say, John, that I have a file, and this file, let me, for example, let's say that I got a copy, I'm the user Eric, and I got the copy of this file. I should not have got the copy, but I find a way to get the copy. So I have the file here, the shadow file. So let me rename it shadow of, let's say, IBM. I got a copy of the shadow file of the IBM company. So I can run John the Ripper on it. So to run it, I can do John the Ripper, John -- incremental, and give the file. So it starts trying. So what do you think is doing in this moment? So it's a, maybe it starts. The password can be 1 character long. So if it's 1 character long, it can be, for example, a capital A. So it compute the hash of the capital A. We have several hash of the capital A. Compute all the hash of the capital A and look in this file if there is a correspondence. If there is a correspondence, it will tell me this user have this password. So it will not take a long time before it starts showing me the password of some user that didn't care too much. So let's wait and see how long it takes, but it will start showing information. So when you run John the Ripper, you can do a brute force attack, which is what we are doing. A brute force attack is when you try all the possible password of 0 character, 1 character, 2 character, 3 character, etc., etc. Of course, if you have a long password, it will take a long time for the people to discover your password with a brute force attack. Because we always start with password with people that don't have password. People that have a password of 1 character, then people that have a password of 2 character, then people that have a password of 3 character. We do that. And another possible attack that you can do is a dictionary attack. You provide a dictionary to John the Ripper. So John the Ripper take one word at a time from the dictionary, hash the word, and compare with the hash that are in the etc shadow. If there is a match, it knows the password that you are using. Okay, so it will be doing that. So so still don't find anyone. Did I run it? Well, it should have found something at this point. Okay, so it's telling me it's not doing the attack that I was thinking. Let me see something. Show. If I do show here. Zero password. Did I do it correctly? Okay. Now I think I did it correctly. The incremental I should not have been using. Look at it already find that root have password 2. You see that? Let's wait a little more. Eric have password internet 2. Why is discover those passwords so easily? In this moment, is doing a hybrid attack. Hybrid attack is when you take words from the dictionary and you concatenate in certain parts random character. So internet 2, it might be even a word in the dictionary, or it's internet plus something that you concatenate at the end in some part in the middle or at the beginning. So it's already found two of the passwords. Let's wait a little more. It will find the rest, you will see. So it's why you should not use words that are in the dictionary, because they are easy hacked with a dictionary attack. And passwords that are short also, they should appear in a few seconds. This password that we put, for example, this AX for Ed Douglas, this capital H for Mary Smith, they should appear in a few seconds. So I think with that, you have all the secret of the password, how they are stored, why it's important to choose a good password, how you can enforce the user to change their password from time to time. You have all this, no? So what you can do as a practice. Oh, but I sent you, because the one that I sent you have some file and they ask you to crack them. So you can take those files, or you can, like we did, we just create user with passwords that are very weak and run John the Ripper on it to see that John the Ripper can discover them. As you can see, it's already have discovered some. It will discover the other one. So I can see that it's making a dictionary attack also, because it's trying those passwords in this moment. All the passwords that are in the dictionary between Gerazo and Genjar is trying those passwords. And here it gives you some statistic, no? The number of passwords that it tries per second. So this is password per second. Okay, I wish we can see appearing the first password, but do it at home. So within 10 to 15 minutes, you should have all the 1-character password, the 2-character password. So they should not last long to appear, they will appear, okay? So I know it's time, so I want to free you from the class, but try it. Okay, I see you in 2 days, no? I see you on Thursday.